Okay, solving a compound linear inequality using interval notation. So we have a compound inequality here, which means we just have two inequalities. We're going to solve each of those inequalities independently, then take a look at how to write it in interval notation. So I have 2x minus 4 is less than 2, and 3x plus 2 is greater than or equal to 20. So we'll start with the one on the left-hand side. So I'm going to solve it just like I would any other equation or inequality by isolating the variable. So I add 4 to both sides, drop down my less than sign. 2x is less than 6. Divide both sides by 2 to get the x completely by itself, which means that x is less than 3. On the right-hand side, start by subtracting 2 from both sides. 3x is greater than or equal to 18. Divide both sides by 3 to completely isolate the x. X is greater than or equal to 6. So I have two inequalities still. Now both of them are solved. X is less than 3 and x is greater than or equal to 6. So to determine what my solution is, I'm going to take a look at it on a number line. This word "and" means that I have to be looking for all of the areas where both this is true and this is true. So on a number line, since both of them are in the positive section, I'm going to start my 0 way over here on the left. Then I have 1, 2, 3, 4, 5, 6. So 6 is here, 3 is here. That's where my two solutions, one end of each of those will be. So it says that x is less than 3. Well, that would be an open circle and everything less than 3. For x is greater than or equal to 6, that would be a closed circle. And everything greater than or equal to 6. Now notice that there's nowhere where my arrows overlap. In fact, they're going in opposite directions and there's a space in between them. So because there is no place where both of these inequalities are true, remember and means that both have to be true, then that means that there is no solution. So I use this circle with the slash through it, indicating no solution. And my answer to this question is no solution.